Welcome back to the PricePlow podcast. This is episode 2 with Chad Kerksick. In our first episode, we talked a lot about the ISSN, but today, in this episode, we're going to be talking a lot more about study design, a few specific ingredients. I kind of want to jump right back into it. Mike, I don't know if you want to give another intro for Chad, but I think I hope that everyone already listened to episode 1, and I'd like to jump straight into the big discussions about study designs.
Yeah, I agree. So, Chad, one thing that you mentioned in the beginning of the last of our introductory episode was that your first study had a lot of mistakes.
Sure.
So,
Yeah.
would you mind explaining what the mistakes were? If you don't mind, I don't want to embarrass you or anything, but we all make version 1.0 is always going to stink, whether it's a business, a book you're writing, whatever it may be, a website you're designing. So it's just how it is. But yeah, what did you learn there? And then tell us, like, if we have an ingredient that we want to study and make sure, we have good data, how you'd like to design your studies for, let's, gear this towards performance a little bit more.
Yeah. So, and I think, Mike, there's lots of things that a person like me starts to think about. So this could be a pretty long-winded, I have long-winded answers. This could be a pretty long-winded answer.
Uh-oh.
But, so just wave a flag or something that first study, in fairness, I think that was probably I was in undergrad. So that was 97 or 98. And I think we ended up not controlling the dosages between the two groups or something fairly fundamental to the design. So I highlight that because if I'm teaching if I'm really trying to work with my students to help them understand some things, and as I go, we're working through a design, there's some fundamental elements we always want to try to avoid, things that are just fatal flaws, just fundamental aspects that you simply cannot trust the conclusions based upon the flaw or whatever it is. So, those examples can be a number of things, but I think so. If we're talking about a training study, not randomizing the people into different groups based upon baseline strength, if we're interested in strength as an outcome, or we a lot of times will do baseline fat-free mass. Because we get it relatively quickly from the DEXA, fat-free mass and strength, not perfectly, but kind of related, go hand in hand. So I think, just creating some level of equal distribution amongst the groups is always a very, very important element. One of the things that I did say in a recent presentation was, and others may not feel the same way, but I think that, if a study is randomized and it's blinded, ideally double blinded, and it has a control group, some type of, placebo control, that's a very, very solid foundation upon which any study can be built. So I think along those lines, you should always really try to strive towards that. Because in today's day and age, I really can't think of a reason why you wouldn't do it. Although we did actually just recently publish a study involving kefir where we purposely didn't blind the groups and we explained that. So there are some unique elements. But I think with a strength study, obviously, making sure of, the training background of the participants, how well are they trained? And then I think many times if we're talking about, if we're interested in, trying to, kind of direct so many times for some sponsors, a certain demographic might be valuable to them. They've got consumer research to suggest that, hey, more women are buying this product, or men of this age are more interested in that. Getting that information, and then obviously setting criteria to make sure that we get a group of data, or a group of participants, that represent who we're after, right? Because I think one of the things that happens a lot, and it's just people just not being disciplined with how they communicate science, but it's you find a study because it shows a certain outcome on something you're interested in, and it was done in 70 to 80-year-old men, and they're talking, oh, this is great, you should do it, this is amazing, and they're like, yeah, but we're really thinking that this is going to be something for 30 to 50 year olds. So those are, those are some things that I think we can really be cautious about.
Can I ask?
That's kind of my first approach, I think, at that answer.
I think a question that a lot of consumers have when they see trained individuals, and you kind of mentioned this before, well, what is the standard for trained individual? Because I mean, I think a lot of consumers would be thinking it's someone who is like a high level lifter, but
Great
people
question.
don't consider that that's actually really like the 1% as well. So
Yeah,
what's your standard for that?
that's a really great question, Ben, and it's something we spend some time on, and it's something I would encourage almost any group who's interested in doing a study to really think about what words like trained, elite, competitive, um, athlete, what those terms mean. And there's been a paper or two published, International Journal of Performance Physiology and Performance, or it's a Human Kinetics journal, but where they really did a nice review that tried to create systematic criteria of what represents elite and what represents collegiate or trained, and so on and so forth. So there is one of the problems with that paper, though, is that it's just when we're talking about like a resistance training study or strength and power outcomes, and those qualifiers or categories might be different if we're talking about somebody who's doing endurance related work.
Sure.
So we always have to have that as a caveat. So I think, Ben, our work's not perfect, but I think some of the things that we've done in the past, and Mike, one of the studies that you're wanting to talk about, and I can really kind of jump right into that, with the study that we conducted with ramps, which is essentially Dileucine. We had a baseline strength threshold on the upper body and lower body side. So you do a baseline strength test, and if relative to their body mass, if they're not above a certain ratio, they're out. And we just use that as a raw, crude indicator of either they've been exposed, because we feel like if they've been exposed to reasonable prescriptions of exercise, of resistance exercise, that they should be able to meet that threshold. And that
For
one
instance,
works
like being able to bench your body weight or something like that.
Yeah, something along those lines. Yeah, and there's groups like the American College of Sports Medicine have some tables that kind of show some ratio, give us a little bit of guidance along those lines, and then from there you can also go through kind of any series of questions asking them, how many days do you train? You depending on the study or the detail, you can break it down into, do you use the back squat exercise? Do you use the leg press exercise? How many sets do you typically perform on a scale of 0 to 10, with 10 being the heaviest, hardest load that you've ever lifted? What would you say the average, load is that you lift? And maybe you're looking for somebody who's, not always picking up the pink dumbbells when they do their resistance training workouts, so those are all the things I think that you can try to do, and then of course you can ask them, how many years have you been training? I don't really like that question, because, you could take somebody who's, you look at myself, it's like, well, I'm 47 years old. I started resistance training, like when I was 18, and I really haven't stopped, so it's like, oh, I've been training for 29 years, like that totally screws up that number, when you get somebody like that. So you have to be cautious about, so that's where, like I like days per week, sets per week, there a lot of it could just figure out, how you, but you always have to be really cautious. I'll tell you, there's no universal set of questions, because there's always been times where, like, man, this would have been helpful if we would have asked this question.
Well, it's funny because I ask because of something you had said before about really finding the population that's most important for the purpose. Because a lot of times people think, oh, they didn't actually get trained individuals. They're thinking that what they would like to have in a study is everyone's favorite meathead from the gym, who is like this the image of muscle or whatever. I a lot of times would rather have a little bit less of a trained individual, so they're actually a mainstream individual where the supplements are actually going to be like relevant when they're being sold to a normal consumer. We previously talked about your affiliation or your help or whatever with First Form. They work with extremely mainstream individuals. If you were constantly basing our data off of Tia Claire, it would not be relevant to the consumers of these supplements. And it's funny. I ask about the minimum, but I also ask because I wonder, is there an upper range of what isn't relevant to the consumer anymore?
Yeah, and I think that I think the answer to that is yes. I think there is an upper range, but I think it's always it's going to be context specific, ingredient specific or population specific or whatever else, And so, like, Ben, I'll give you an example of how we tried to control for that upon screening with one study that we did. We did this study with Dr. Ralph Yeager. We were looking at the impact of a yeast beta glucan on its ability to kind of modulate an immune response to like a challenging bout of exercise. Well, if you look at immune and oxidative stress responses, if you take an untrained individual, they're going to have a huge response because those systems are just not used to getting stressed. So you want to try to avoid them. But then you also, if you take really highly trained people that are really getting consistent volumes in terms of running, they have unbelievably developed and very robust systems. So they may not be the best reflection either. So we were literally truncating our screening on both ends of it. And it was an epic pain in the ass because we were screen failing based upon those lines. But going back to the RAMP study, we tried to use a fairly rigorous approach as well. And we had a lot of screen fails. So I would say that project, more so than any of the others that we've done in the last few years, I feel really, really good about the population that we have included in that data set. It took us a long time to get through that trial because we had significant screen fails at the beginning because of the different criteria that we employed. And then you always have the ongoing aspects of humans being humans or humans being knuckleheads and they drop out or quit or whatever. And you spin your wheels a little bit that way as well.
Yeah. So if in your job role, if I were to ask you, Chad, what is Dileucine? What is RAMPS? Is it your job to understand that in the biochemistry, or are you like really putting together exercise science and like the research itself? Do you get into the hooks of it?
I mean, I get into it a little bit because I'm personally intrigued by it. I personally want to learn it. I personally want to think and evaluate how and where does it fit, maybe to what extent. But I think if I separate that answer from, if we get engaged in a conversation about, having my lab run a clinical trial for somebody, and here's the ingredient and here's the type of study we're thinking about doing, here are the outcomes we would like to be able to address, I don't necessarily need to understand the nuts and bolts of it, the true backbone or biochemistry of it. I mean, and that's not always the case. I mean, even as soon as I say that, I'm thinking, well, but sometimes you do need to so it's not a complete blanket of no, I don't need to understand it. But I would definitely think that you don't really need to understand it anywhere near the level of like a true synthetic chemist might need to understand it. And at that level, I think, because where we're being employed or our part to the process is kind of taking our understanding and command of clinical research design, human research participants, human studies, and the ability to conduct those studies and design a rigorous investigation that can kind of withstand, withstand the rigors of science. And if we see differences, then we should be able to have some level of confidence in those changes.
It seems to me like an analogy. When you use AI, you have to know the correct prompts to get the answer that you want. I feel that it's important for you to at least understand it chemically a little bit, because that way you can design the study to make sure that you're getting the right amount of data, the right kind of data. Not to say that you ever game data, but to make sure that you're testing the right things in the right ways because you understand the product.
Well, and and Ben, you're right, and I think one of the most important ways in which you need to have an understanding of the ingredients is, like its pharmacokinetic pattern, like how quickly it is appearing, or depending on the mechanism of action, like, how long do we need to supplement with it before we can even reasonably, see some changes. It's like if we have a phosphatidylserine product or like an omega-3 product or a beta-alanine product, and we only dose them for a week, and we don't see anything, like that's a fatal flaw. That's a fatal flaw in the design. And honestly, that should be shame on me as a researcher. Like that's how I look at ourselves, in the sense that if somebody would come to me and say, hey, look, we want to look at this, we want to look at the ability, I would say, well, do you have data to show that this can actually, anything to show that it can actually happen in this time? Because our typical time course or pattern is, the science suggests this. So that's kind of ways in which we'll take what we know, apply it to design, and potentially help people, avoid designing studies that are literally going to fail. They fail before you even start.
I would say from our perspective, all data is good data, and it's important to know if an ingredient doesn't work in 1 week, just as important as it is to know when it does work. But I can imagine from your side, when significant amounts of cash are being spent for this, you want some sort of outcome that is helpful and not just a negative outcome.
Yeah. I mean, in general, because of course that, now, don't get me wrong, as some companies start to iterate and innovate and make, various modifications or manipulations to various molecules or ingredients, and they think that it's going to alter the time course or its ability to get into the cell or anything along those lines, then you somewhat have to, you still ask to see the information yourself, because you have to write an introduction section. You have to be able to understand it a little bit. But, as those types of innovations happen, there certainly may be things where you're like, okay, well, let's give it a go here. Let's see what's going to happen.
Mm-hmm. So with respect to the RAMP study, just so I make sure I have the right reference here, are we talking about like what you had a poster presentation on last year at ISSN in 2023, Anthony Hagil, effects of 10 weeks of Dileucine supplementation on athletic performance? So I have that cited in one of our articles. Did that ever make it to a full publication, or
Mike? I met with you're on a roll with asking me questions about things that we're getting taken care of.
So I stressed you out for the weekend.
It's all right. That paper's under review right now with a PLOS One, and technically that's really all that I should say. So. We just got revisions back. We just got revisions back on it. I can say that. I'm not going to tell you what the disposition of it was, because I don't anything along those lines. But yeah, so ideally, hey man, fingers crossed. It's been, we've had it under review for a while. That we can continue to navigate the peer review process, and it'll be out. If not, if it gets reviewed or sent back, we'll try to make some revisions and changes and send it somewhere else.
Okay, so I guess more general question, because there have been times where there's something that was presented at ISSN. I think like some nitrosamine studies with Nutrition 21 in the past. It's presented at ISSN, and I've like updated the citations so that you see the poster presentation 1 year, and then eventually it makes its way to publication. I kind of still cite the proceedings from ISSN as well, though. It's generally like the same data, right? Like I guess I'm not. Does anything change from start to finish in terms of what you have in the proceedings versus what eventually gets published?
I mean, I think in many situations they can, so lots of different, I think, things or examples to talk through along those lines. I think many times, like an abstract is, 300 words, 350 words. So, you might only present one or two variables, because you've got to, so that's one area where a paper will typically have, maybe they'll have more time points, maybe they'll have more variables that are being measured. But to your point, if you're literally doing V of E with one outcome and one time point, those variables really shouldn't change. There might be situations where, as you start to dive into the data a little bit deeper for a scientific manuscript, that maybe you look like, this person here, like their response isn't characteristic with the rest of the group. And, maybe you might decide to pull somebody out for some type of a reason. And anytime you do that, your means and standard deviations might, will certainly going to take a subtle change, and that may impact the p-values, because there's always decisions that have to be made in terms of, is this a true value? Is this an outlier? Yes, we've got guidance on when those things, when they are and when they aren't. So I think those are all reasons why those, the proceedings and the full manuscript might be different.
Gotcha. And
I
so,
think with this particular study, we did, I think if I'm right, I think we did a preliminary abstract where we only had, I think we had 5 or 6 less people in that abstract than what we had in the full paper. So we were still collecting data. We broke, and analyzed and presented it as an abstract, and then finished up a few more people.
That's pretty cool. So can you talk about the design of the study, like 2 grams of leucine versus 2 grams of the placebo? I think it was 2 grams of resistant starch, and then 2 grams of dileucine monohydrate, which is RAMPS, was like what we would call, I guess, the active group, or
right. Mm-hmm. Yeah. So I think with this project overall, we looked at, try to pull up my design here. And of course I don't have a picture, but we did a 10-week resistance training study with this project overall. We recruited trained males, and we kind of talked a little bit more about some of the criteria that we used to substantiate that they were trained. Each person was randomized according to baseline fat-free mass.
So basically, you're just not going to put all the swole dudes in one group. Is that kind of where the randomization is?
Yeah, and I think that's it would have made, to me, it would have made perfect sense for us to maybe randomize according to baseline bench press. Bench press 1 RM. That way, you don't put all the strong people in one group, all the weak people in another, and wow, what do you know? The group that had the weaker individuals saw the greatest strength gain because they're just not as close to their genetic maximum, as we might refer to it. The other reason why we use fat-free mass a lot of times is there's oftentimes this question about, well, if we're using an absolute dose like 2 grams, can we, are we going to deliver a more effective dose per kilo of tissue? If we have individual, so if we try to spread out that fat-free mass, then we get a little bit of a sense of assurance that the relative dosing.
Yeah, because if you have just a bunch of 130-pound people in a group by chance or whatever, that's just a higher dose of leucine per kilogram of body weight or whatever.
Yeah,
that makes sense.
Yeah, because I think that there's always kind of this ongoing tug of war, right? With scientifically, it's probably better to dose according to kilo of fat-free mass. But the reality is that when it's being marketed or sold, like you're not going to sell it in partial, you're not going to sell it in gradiated dosages. So you have to, so I think a lot of times what we'll end up doing is, we'll take the absolute dose, randomized according to fat-free mass, and then we can calculate what the relative dosing was per group, and kind of demonstrate that if there's questions about that. But yeah, we really followed a very traditional resistance training design with this study. We had three groups that were run in parallel. We measured changes in strength, strength, muscle endurance, body composition, across the entire study. And we're basically just kind of looking at changes within those different groups. I'm going to try and pull up my report.
While we're on that, one thing that we've noticed recently, and I don't know if this has anything to do with your influence, but Mike keeps commenting that over the last maybe year or two, studies have gotten into like a lot more hardcore training. We found that even like the placebo groups are gaining fat-free mass, which is always awesome to see. How do you set up the training? What's your favorite way to have them train?
Oh, I mean, I try to simplify it as much as I can, because, the last thing that you want to do is give a human participant a reason to get frustrated and decide to quit the study. Mm-hmm. Now the problem with that is that you'll get your Facebook warriors when you're running a sponsored post that'll say, they'll make comments, they'll make comments about your design or whatever else, So like, but our go-to on a resistance training study, we usually do 4 days per week in a split body format. So we'll do 2 upper body days and 2 lower body days. We'll generally have, we have exercises that target, all of the major muscle groups generally, and around 3 sets of 6 to 10 repetitions at loads that are, somewhere around, 70 to 85% 1RM. So if you look at the ACSM guidelines and NCAA guidelines, we are right smack dab in the crosshairs of where those designs need to be. We actually published a study when I was at Baylor during my PhD that just looked at the training program. So we literally have data that shows that the training program, without any supplementation, causes significant increases in strength and fat-free mass. So that's why we go back to that. But again, with all of the iterations of periodization and loading schemes and everything else, you can only imagine what type of comments we'll get, from the social media world about what they think about our training program.
So when you say simplify, you're talking about like leg press and extensions and like machine pressing for chest and stuff like that. I as a retired powerlifter, I can see both sides, but something that I think a lot of people don't understand is like the complexity of like motor pattern learning, and that if you're taking, we're talking about trained individuals here, but if they're not great back squatters, if they I don't think I've ever seen Mike do a squat with a barbell on his back, and so like I wouldn't test him doing it the first time. Like that's a complex movement that people need to learn and understand. So
yeah, and I think right now, Ben, you're getting into kind of a kind of what I would say like a fundamental aspect of almost like study design creation. And I think again, you look at different research sponsors per se. Like I would say, like that's my job. If you guys contract, that's my job to make sure that we get those things taken care of. A company shouldn't really need to be worried about those types of things. But to your point, so like that's why we use bilateral leg press for nearly all of our lower body strength, because it removes a lot of that technique element. Because you're right, if you get somebody on a back squat who's not really that skilled or used to it, they're gonna reach failure, but it may not necessarily be muscular failure. It might be more of a technique failure, and that's not ideally what we're really trying to get after. And then if they go about and follow our training program and they start doing more squatting and they get better at it, their loads are going to go up, and there's a portion of that increase that we're going to measure that is because they just became better at squatting. So the leg press does a little bit better job of negating that. It's funny because like if anybody ever reads a study and criticizes like, why are they doing isometric knee extension? Nobody ever does an isometric knee extension, and they just go on a rant over why in the hell did they measure that? Well, the answer is because you get them on a isokinetic dynamometer, and you literally have them strapped in. Their shoulders are strapped down, their off leg is strapped down, their foot is strapped down. We'll measure femur length, we'll measure everything. It is the exact same body position, and you push. So you've removed all of those technique elements. You've removed all of those aspects. It's a constant tug of war with study design, but you're like, yeah, but nobody ever does it. So what if my people that are looking at the study, they think the results are useless or invalid because they didn't use a squat or they didn't use a leg press. And you're like, okay, well then we'll do a leg press. You know what I mean? So it is this kind of back and forth per se.
My only takeaway is that I want one of these knee machines in my gym. Like if people are afraid of like it being like so much different from the squat and like your data looks so much better, then I seriously need one in my gym.
We keep hearing how horrific they could be when you're going to like full tilt, trying to destroy muscle and everything.
Let me tell you what, there's a test that we'll do that's for muscular endurance. It's called the Thorsson test, and that's obviously the first author who published the paper, but it's 50 reps, isolated, single leg, 50 reps, push only. So quads only. You're just basically doing leg extensions, push only and then just let it drop back down. Push as hard as you can, 50 reps. And it's really cool because you can get peak torque, so you peak torque, peak power. But what the machine will do is we'll get how much work was done during the first 15 reps and how much work was done during the last 15 reps. And you calculate a deficit. Great test. Significant predictor of fiber type prediction, fiber type levels. It sucks.
Do you?
It's not fun.
Do you do any of these tests before you make the subjects do it?
So I do really like for our students to go through them and do them. I don't do them as much anymore, not necessarily because I'm afraid. I mean, I've done them in the past. So I would say yes, nearly everything that we've done, I've done myself. But I really do. I think just from a teaching experience, it's just really cool for the students to go through it. Plus, I think it makes them better data collectors because they can think about body position, or they can think about rest or fatigue or everything else, and we get more standardized testing. So we usually do have we at least we try to. That's so
cool.
Sweet. Chad, okay,
Yeah.
I got to take you, I want to get back to ramps a little bit. I got to take you out of your comfort zone a little bit.
Okay.
Let's say I got a brand spanking new product line of supplements, and we could put ramps Dileucine into any product, like a standalone capsule like Muscle Tech did, or a pre-workout intra, like post, knowing what you know about this amino acid, how would you formulate with this ingredient now?
Well, Mike, that's not my job.
I know.
That's
I took you out of your comfort zone.
Shame on you. Shame on you. So I think, man, that's a hard question for me to answer. Because, I mean, the data that we're showing from our study, and we showed that in the abstract, was that it didn't really move the needle very much from a body composition standpoint. We saw good responses from our training program, but we saw some significant improvements in lower body strength, as well as basically the number of repetitions that could be performed.
Mm-hmm.
So, I think, it wouldn't. I don't necessarily think it makes sense to add it, in like a pre-workout per se, because of where it would end up. But I mean, I think certainly if there's a scenario where, dosing it alongside, not a higher dose of protein. Let's say maybe you have a product that's on kind of you want it to be on the lower end of protein.
Mm-hmm.
So we're not really quite sure, or if you're delivering it alongside like a plant protein, that layering Dileucine in there certainly might create an added advantage, because of the kind of the delivery from a muscle signaling perspective. I have talked to our sponsors quite a bit, with that. I mean, I think that with what we showed, I think it would be really, really cool to move ramps or Dileucine into, like an older population, like a sarcopenic population, because we see some compromised muscle contractions, skeletal muscle health. And we also see that they're a little bit challenged to get enough dietary protein in their day, mm-hmm. as well. I also do wonder, this is me just wondering out loud. It's not a formulary question, but I do wonder if there's a role for it within, like weight cutting, in the sense that, calories are scarce, calories across the board are scarce. So does a shot of something, something along the lines of Dileucine, does it at certain times, can it help create a heightened environment to help promote adaptations in a scenario that's otherwise void of nutrients.
Cool. Okay. Well, I thank you for having to think that through. I figured we'd get something good out of that, even though I had to take it out of the comfort zone. So if we could get it to taste good, we could talk to Michael Alfaro, put it in a lower protein bar. I'm not sure if we can fit 2 grams in there, but yeah, the idea of a shot where someone's not going to get a ton of calories in, but maybe get in a little bit extra Dileucine, that could be a cool play as well. Okay, very cool.
Because I think when we look at it from the side of things, if we're looking at like the weight loss scenario, body physique management. I mean, again, one of the first things I'll always say is like, we're not interested in weight loss. We're interested in fat loss.
Mm-hmm.
Like we don't want to lose lean tissue. We don't want to lose fat-free mass.
Mm-hmm.
Like we want to lose fat. So let's
Right.
call it fat loss and not weight loss. So, and we know, right, that to really do that, we have to be in a deficit. We've got to drive a deficit from calories. We need some resistance. We need the resistance training stimulus as well. And then, we've got to make sure that we're delivering enough amino acids to help support, kind of whatever adaptations or trainings can occur. So I just wonder I have wondered within that context that does it have a role? Our study did not examine that in any way, shape, or form because they weren't hypocaloric. But I do wonder. It's just one of those things that I do wonder about, because we do see situations, right, where there's been some studies published where you deliver suboptimal doses of aminos or whey protein, and we add in a little bit of extra leucine, and we see some support for like muscle protein synthesis rates. So there is some evidence along those lines. Yeah. So,
question for you. You talked about the lack of change in body composition. How long was the study for?
10 weeks.
Okay.
Yeah. So we supplemented for 10 weeks. They supplemented every day. They trained 4 days a week. We did give all the participants kind of a calorie target. So we kind of made an Excel calculator, gave them a calorie target, gave them kind of a list of some nutritional strategies or priorities to try to adopt or follow, gave them a protein target that aligned with, a lot of different recommendations surrounding protein. And then we also did assess diet periodically to help get an idea of how well they were landing where they needed to be. And honestly, overall, they ended up doing a really pretty good job, So like that for me, for these types of studies, that was another, big study design factor that I was really kind of interested in. I remember, so there's kind of a number of those things we could talk about.
Mm-hmm. So in this study, you measured dry lean mass. So is that a mathematical calculation?
Yeah,
it's
one of those things that we would use. It's a calculation that we can use along with our impedance analyzers like BIA or BIS. It kind of gives us an estimate of body water, intracellular water, and then there's a mathematical computation that we can follow that kind of gives us dry lean mass, which is intended to be more of an indicator of just the true lean tissue versus the water component. So
gotcha.
It's
okay.
You're just slicing that tissue up in different directions, and so I will say it's as much as we can do these different types of things, this is one thing for just people to consider. If you look at a lot of the changes overall that we might see in a DEXA, and if we also do BIA and we get body water changes in intracellular, extracellular water, we calculate dry lean mass, the ship is all honestly is almost always moving in the same direction. Like very, very rarely will we find a scenario where we're seeing no changes in a number of these family of these markers, and then there's just one that's like, bam, so.
Got it.
Awesome. So I think you might have something ongoing, but obviously right now, and I'm changing the subject to the GLP agonist drugs. And so we've seen, obviously this is a huge thing in the news. So different dietary supplement companies and stores are taking different approaches to these types of drugs. If, are you either like, how would you prefer to make a study surrounding these? And are you currently involved with any of them?
Yeah, I don't, Mike, I that's a tough question to, answer, I think, because, like if we look at the GLP-1 agonists and what we're seeing and hearing in terms of weight loss and everything else, again, like my mind, a lot of times I just try to simplify the question, and I'm saying, okay, well, if we're just interested in body composition changes, and weight loss changes, well then, it's like, okay, well, we've got to do something longitudinally. I think, we still need to educate them, and we still have to understand what their diet is. We still have to educate them on what their diet needs to be. Now, those drugs are, obviously, I think we know, right, that one of the big mechanisms that it hits on is it really curbs somebody's appetite, feelings of satiety. So, we would anticipate that energy intake would go down, and, so measuring body composition would be good. If we really wanted to get at, like the quality of weight loss, we might want to add in 2 days a week of resistance training, just a very, very modest stimulus, or 2-3 days a week. So I think that's kind of how I would go about it. Now in terms of, are there studies that I've been involved in designing, so I have, done some advisory work, and I'm doing some ongoing support with NNB. NNB is a ingredient manufacturer based in China. And, so they have, there's been some communication and interest across social media in a number of different dietary supplements that are thought to be kind of natural GLP-1 agonists. So now you've skirted away from the pharmaceutical, and now we're in that dietary supplement space. But I think that there's still a tremendous amount of information that we need to learn in terms of, is it working? Well, how well is it working? Are we truly going to say that it's working as well as a drug? That's why kind of doing these studies to help, really helps to provide some context and kind of relevant outcomes along those lines. So the first, so the berberine is one of those ingredients, and NNB makes a form of berberine that's dihydroberberine. And so I helped them design just a very, very initial pilot proof of concept study to see to what extent is, their dihydroberberine, is it impacting, mood, appetite, weight loss. I think we're measuring body composition. We are going to measure GLP-1 pre and post, changes in glucose and insulin status, digestive function. We're kind of, we're looking at a number of different outcomes. Because I use, the pilot and proof of concept aspect, we moving that trial along, trying to get some data, some evidence to be able to evaluate and communicate. I think they're going to supplement for 6 weeks. And that's all we're doing. They're just going to supplement. They're not going to follow any kind of an exercise program, any type of a diet program. We're literally just going to give them that or a placebo, a couple different dosages, and see what happens along those lines. So that's ultimately what trial I've helped them design. It's not the only study that should be done. It's just the first study that's going to be done.
That's awesome, because we obviously see that berberine does have some of these GLP-1 agonism effects, but at the same time, semaglutide, I don't think anyone's really buying it for an anti-diabetic. Well, not anyone, but a lot of people are not just buying it for an anti-diabetic mechanistic effect. They're buying it because it works insanely well in curbing appetite. But if you do a quick check on the research, we really don't see a whole lot of research on berberine with respect to appetite. We know it has great anti-diabetic effects. And, there's one study showing at a full dose, 1,500 milligrams per day, standard berberine outperformed metformin in some levels, and like lipids and a few other things. But I don't think they really ever frequently get into appetite. And that's kind of like the hot thing. So it's worth knowing, if nothing else. We're already confident that berberine does a lot of really, really cool stuff. But this is definitely something worth understanding. So I'm kind of curious, how would you like to measure appetite? Is that subjective, or can you objectively, you can't put these people in a jail cell and measure everything they eat. So what's your take on that?
Yeah, I think the most common approach that's done with, different research approaches is do like visual analog scales, to where, you would just ask them a perceptual question in terms of, I mean, like how would you rate your appetite? 0 is, on one end of the spectrum, and like 100 is on the other. The hungriest I've ever been. And you a lot of times will kind of iterate that question to get at hunger and satiety and appetite and cravings and emotional aspects as well. So very rarely will we do just one visual analog scale on its own, because a lot of times you want to try to see if things are collectively, so that's one approach. I think that's probably most commonly done. That's easy. It's relatively inexpensive. It's quick, so there's a lot of advantages from a study design perspective. I think another approach you could simply do is really trying to be fairly detailed with dietary collection, dietary records. And if you recorded dietary, intake via records frequently enough, you very well may be able to show that, hey, at week 0, they were consuming X amount of calories per day on average. And after 4 weeks, they were consuming this. And after 8 weeks, they were consuming this. That's certainly possible. One of the biggest problems with that is the track record of the overall accuracy of dietary intake is absolutely horrendous. It is terrible. It's a nightmare. It's one of the worst parts of what I do, because it's so fundamental to questions related to, can it help me lose weight? Can it help me gain muscle? Like, that's you can't fundamentally answer that question confidently if you don't know what they're consuming.
Right.
But then to go and ask somebody, hey, can you write down everything that you ate or drank for 3-4 days and do that? They don't do it. They'll do one day, and then it's just challenging for people. A lot of times people don't think about their diet the way that researchers or enthusiasts think about their food. Like, I had a sandwich, like, well, did you drink anything? Oh yeah, I had a soda. Well, how big was the soda? It's, by the way, it was on that sandwich. And you're like, oh, there were 3 pieces of cheese. You're like, wow, I wasn't even sure if there'd be one. So there's just stuff like that can drastically, and then you extrapolate those things across, and that's why dietary intake it's a nightmare. Mike, another approach that's commonly done. We don't do it very much because you really need a unique scenario, but you made reference to, like, kind of lock them up in a jail cell. Now, don't get me wrong. There are large clinical research groups a lot of times at big research hospitals that absolutely have those. They can check people in. Mm-hmm. Those are cool. Those are great. They're not practical. People's sensory inputs for eating and everything else are going to be drastically altered if they're in an institution along those lines. I think some of the neatest scenarios is there's some research groups that they'll create a social environment. Literally, they'll create a social environment in, like, an open room, and they'll have palatable foods available, and everything's being recorded. And you'll watch how much people eat, and you literally quantify how much people eat. Mm-hmm. So now those studies are pretty rare because they're challenging and expensive and everything else. But so
right, really cool. So yeah, it seems like there's 2 decent paths. Like, one, adding something to the people who are already suppressed from the appetite if they're taking the drugs. And that actually, ramps Dileucine might work pretty well for that. But then also just to get more aminos in, but then also considering if there's any, like, natural alternative that's probably not going to be as strong as a drug, but might have some effects. The mouse study, I'll cite it in the show notes here that I'm looking at. The Berberine group did have reduced intake. So I don't know if we see it in humans. It would be so awesome if you had a pilot study published, even if it was, I don't know, what do you consider a pilot study? 5 people? Like,
I mean, the answer to that question is, it's anything but straightforward. And, but I think, I mean, 5 per group, 8 per group, I mean, a lot of it depends upon the study design, and different things along those lines, but I think we've got, so it's just, it'll, the reasons for the pilot a lot of times are just to prove your concept, just to, like, is the needle moving at all? Is there any reason to keep going forward down this path or should we stop and take a different approach? So you have to realize with a pilot that you might invest 6 months and everything goes up in a heap of smoke. But it will give you tremendous insight into saying, well, we're not going to do that again. And if you believe in what you got, what you're studying, and you think that there's something going on there, then you change the dosage, you change the environment, you change this, you try to examine it under different context, and then do it again.
Can I ask, this is slightly off topic, but still on the topic of Ozempic. One of the big things when it comes to supplements is the claims that you can create. And so as you study GLP-1 agonists alongside supplements, is there any consideration when you're building the study to make sure that you're coming out with claims or data that can be marketed for supplements?
Well, yeah, I mean, I think that there's always, kind of an interest, particularly if we're talking about a commercial sponsor, right? To where, you're designing a study that is gonna, if the data turns out, from a numbers perspective, that support the claim that you have those things discussed and addressed, so, and I think a lot of times that's probably, I think, one of the biggest differences between doing let's call it like an NIH type of a study over, over Berberine versus doing something, kind of relative to a company. It doesn't necessarily mean that the scientific design is different. It's just more about the, how you go about examining or designing, what direction you may take. The things at on the very, very initial end are a little, might be a little bit different.
Right. Okay. It's one of the big discussions that we've had as I'll admit, Mike and I were kind of, we didn't really want to talk about Ozempic and GLP-1s. We really don't want to talk about pharmaceutical drugs as we get into this, but it became obviously like, something that we couldn't have a decision about. But as we do get into it, we want to make sure that we're talking about everything you spoke about in the last episode: healthy nutrition, training, all sorts of other stuff. But if we are going to talk about it, it's talking about how do supplements help with the experience? How do supplements help augment them? So maybe you could use less of it. How does it help deal with side effects or all sorts of stuff around that?
Yeah, because I mean, I think, and I mean, I'm not a Ozempic, GLP-1 agonist expert.
Sure.
I haven't dove into that literature that closely, but what I've learned just from afar and everything else, I mean, they're expensive, number one, and I think that part could certainly be a barrier for a number of people. If there are, kind of different side effects that may come up from taking the prescription power and level of them, that may be one consideration. Then I think, there's also people too that they would prefer not to take a pharmaceutical drug if they don't have to. So there's that element of it. I think on the flip side of the conversation, right, is, I mean, drugs are, reviewed and evaluated for, certain, outcomes and safety and efficacy and claims. And when they're approved to do certain kind of things, they're the overall, the power at which they work. I mean, sometimes it can be replicated and sometimes it can't. I think Berberine has been such a unique example in the sense that there is some published evidence to show that head to head it may do just as well. And then I think that what we've, what NMB's tried to look at on the dihydroberberine side is that, their dihydroberberine, gets, is you can use a much smaller dose. So from a formulation perspective, how you can use it, the number of times a day you can use it, it creates a number of different discussions, so that's why I think that ingredient has been of interest to them. So I think to be able to kind of compare that against Berberine, and different things along those lines, is certainly where, we can see just how that data, how that information tells us things moving forward.
Yeah. Well, yeah, see, Chad, you're thinking formulations now. We got you going with the formula. Well, no, yeah, we are long been big fans of dihydroberberine, sold as GlucoVantage by NMB Nutrition. We have previous podcasts and videos about that, so we'll link to all that in the show notes. Chad,
and I think, just to mention it, we did we published a small, a pilot with dihydroberberine.
Was that you?
Really,
We covered
yeah,
that. I had no clue.
yeah. So it was N of 5 or 6, but it was we did a randomized double-blind placebo-controlled crossover study. So it was a crossover design, which strengthens things quite a bit. And yeah, we gave a 1,500 milligram dose of berberine and I think 100 milligram dose of dihydroberberine and 200 milligram dose of dihydroberberine and then a placebo. And yeah, we showed that the 200 milligram dose really kind of performed really pretty well in terms of getting berberine into the blood.
Yeah.
The whole, so the thing that we try to highlight with that one is let's not make the study something that it's not. The purpose of that study was to just show that, to what extent does oral consumption of a single dose or of 4 doses of dihydroberberine impact how much berberine gets into the blood? Because I think one of the formulary advantages, right, that we like, that the folks like at NMB is the fact that you can take a much smaller dose. The overall bioavailability is much greater. So the next step was then, okay, well, we know that more berberine is hitting the bloodstream. We know that more of it's going to be able to circulate and touch all the receptors and do what it may do. So the next step is, we need to extend it out. We need to supplement for several weeks and start to see if some of these efficacy related outcomes are, if we're kind of moving the needle on it. And then ideally, if we see some things, that we'll get some things powered up and have a much larger investigation going at some point too.
Okay, so the backstory that was published in 2022. We didn't even know about it until way too late. So once we learned, we wrote our article about it November 30th of 2023, have a blog post, but we use MLA citations. So it's citing Jessica Moon as like the primary author. And so if I go to the study, though, there you are at the end, Chad M. Kerksick. So I don't know if that bothers you that it's an MLA citation that doesn't have your name on our blog, but I would be happy to put Chad Kerksick's team.
No, you cite it however you want to cite it. It's funny, Mike, when I was first couple of years of my PhD, that might have bothered me, or my fact, no, I don't care. We published enough work. It's fine. So plus,
Jessica Moon did Jessica do like the majority of the writing, or how does that work real quickly?
Yeah, so Jessica Moon she's finishing up her PhD at University of Central Florida right now. She'll be an academic investigator in the near future. But yeah, she worked in my laboratory here at Lindenwood when we ran that study, and she was project lead on the whole thing. So from getting the participants recruited, getting all the visits completed, getting everything analyzed, and then she actually wrote up the data, and that's how we handle things. So she's responsible for it. She's first author.
Awesome. Okay. And so it seems like the main correspondence person, or I'm not sure, like the boss in ways, is always the last person. Is that pretty?
Yeah, a lot of time. And that's just kind of discipline specific related things. How I do it, which I think is consistent with a lot of people within the sciences, is the first author is the person who was the most responsible for the conduct of the study, the completion of the study, and oftentimes responsible for writing the paper. Other authors a lot of times serve in various capacities to support the data collection and execution of the project, and then many times the last author is the senior author, is the faculty member running the lab, the person that, and a lot of times it's the person that helped design the study and secure the funding. It's funny, there are some people, Mike, really just for that exact reason of what you said with MLA, is many times senior authors will put themselves second. So the first author, and then it would be Moon Kerksick. But again, that's all.
Awesome.
Yeah.
Okay, Chad, we've taken up a ton of your time. We've had 2 great episodes. I thank you so very much, and wish you an incredible weekend. I know you've been talking for 2 hours, so you're probably pretty exhausted and need a drink of water.
It's all right. Yeah,
But no,
I appreciate
so
but I mean, I do enjoy these conversations. It has been fun. So thank you very much for having me. And if you guys need something in the future, let me know.
Thank you,
Well,
Chad.
how do people follow you? What is your, I know you're not busy on social media. Are you doing anything on LinkedIn? Like what do we do? You can, if there's one, Instagram is at Chad Kerksick, Twitter or X is at Chad Kerksick. I am on LinkedIn as well, so you can definitely kind of locate me through there. And I peruse and I look at it. I will respond to questions sent to me.
I just have a hard, as I told you, I just don't have the bandwidth or the capacity, or a lot of times a little bit of the confidence as well of just getting social media content prepared and put together. So
The imposter syndrome kills me. You should have all the confidence in the world with all the stuff you've published and read and written and everything. But yeah, I understand.
I think it's more about just the design element of it, just kind of
Okay.
making it look cool.
Mm-hmm.
You know, I'll put myself up, you know, to sound egotistical, I'll put myself up to talk about the science side of things. That's fine. I can do that instantly, but it's just more about, you know, making it look cool.
We understand for sure. We appreciate your time, though. Thank you.
Yep.